Hello everyone, welcome to this presentation. I will introduce a recent work, GO-NeRF, generating objects in neural radiance fields for virtual reality content creation. In this work, we want to directly create 3D objects within an established 3D scenes, following the given text prompt and user-specified locations. First, I will talk about the motivations and the challenges of this work. Recent neural rendering algorithms, such as NeRF and 3D Gaussian, they have demonstrated great capability in reconstructing the real world from captured images. However, the reconstructed 3D scenes is not always satisfying, and the editing ability is highly desirable. Moreover, the 3D generation has made great progress, but they focus on individual object generation, and the generation conditioned on the 3D scenes is still underexplored. In this work, we study the lower problem of directly generating objects in the established 3D scenes. There are two challenges in this task. First, previous computer graphics software such as Blender, which is too complex for casual users. As a result, we need to design an easy-to-use interface. The second challenge, we hope the generation process can leverage sense contact. For example, the generated fruits should on the table instead of flying in the air. And when the 3D scenes have different styles, the generated content should align with the given scenes. As shown in the cat case, their appearance varies depending on the scene's style. Next, I will briefly introduce our method. Our method consists of two parts. The first part is a user interface, which determines the generation positions. And the second part is a compositional rendering design that effectively and efficiently blends the generated objects into the 3D scenes. In our user interface, we first project 3D scenes into RGBD images. After this, the users can simply click 3 points on the image plane, which will return a 3D bounding box. This 3D bounding box determines the generation positions in the 3D scenes. Our compositional rendering can be divided into 3 parts. In the first part, we pre-render unchanged scenes content into RGBD images. In the second part, we use volume rendering, but skip unchanged scenes content to render generated content in the 3D bounding box into RGB image and corresponding blending weight or opacity map. In the third part, we blend the rendered object content into the 3D scenes using the optimized blending weights in the image space. After obtaining the composed image, we feed it into a pre-trained text-to-image generation model to determine if the rendered image matches the given conditions using SDS noise. To better leverage the surrounding scenes, we proposed to replace the pre-trained text-to-image generation model with a painting generation model. The right side demonstrates the effectiveness of impacting SDS noise. When using the impending SDS noise, the generated content is more complete. Moreover, the generated content has the oversaturation problem, as shown in the left image. To handle it, we propose a saturation loss, which encourages generated content to have saturation values close to those of the scenes. As displayed in the right image, the saturation loss alleviates the oversaturation problem. In practice, directly generating objects in 3D scenes sometimes introduce artifacts which closely resemble the scene's background. To handle it, we adopt background augmentation during the optimization process. Following previous methods, we also use other regularization and training strategies to boost the performance, such as geometric noise and cost-to-fine optimization. At last, I will show some results. There are some 3D scenes with generated objects at user-specified locations. From these scenes, we can also observe some rendering-related effects, such as plausible shadows and reflections. Even though they are not physically correct, this phenomenon demonstrates the great potential of using diffusing priors, learned from large amounts of data. We compare a method with blended NeRF and manual placement. The blended NeRF generates low-quality and incomplete objects, while the manual placement ignores the influence of scene's context, leading to the same cat in different scenes. On the contrary, all methods produce cats with different appearance, as the shallow shadow around the basket is generated to enhance the realism. The new 3D scenes can be rendered into stereoscopic videos, which provides immersive experience when watched from VR headsets. Thanks for watching.